So now, you just got done getting a time on 50 meters, okay? And so now what we're gonna do is we're just gonna compare what you can do in 50 meters to a bunch of world-class athletes. All right, we're just gonna see what it looks like. So the first thing I want you to do is I want you to write your 50-meter time in here. I'm gonna just use somebody's time from this class so that you can kind of see what it looks like. Nevaeh, give me your time. Oh, give me a second. Okay, so I'm going to use 9.5. Now, keep in mind, everything else will be different. Nope, you use your time. You're all going to have to do your own math. Okay? So, the first thing they're asking us for is average speed. Now, you have done speed problems before. I'm going to put the speed triangle up here. Speed is equal to distance divided by time. In the speed triangle, this line represents division, this line represents multiplication. So, in every physics problem, you have to have 4 different things. The first thing you have to write is the equation. And when you're looking for the equation, you ask yourself, what's the unknown? Well, speed is the unknown. So what's my equation for speed? Yep, distance over time. Now, the number substitution, all you have to do is just write down the numbers that you're going to punch into the calculator. The only reason that I have you do this is because each of these problems are worth 4 points. If you put the numbers into the calculator backwards and you get a wrong answer, I mean, of course that's going to happen if you put it into the calculator backwards. I would only count 1 point off for that. So what I want you to do is sub your numbers in. What's the distance? 50 meters. Then you're going to input your time, which is going to be in seconds. Nevaeh, when you do the math, what is 50 divided by 9.5? What? The hundredth. What? 5.26. Okay. And then for everyone, your unit is going to be meters over seconds because speed is a derived unit. Whatever you did, yards, feet, miles, over how much time you did it in. Okay, now, this is your speed in meters per second. You might want to circle that. The next question is asking, what is your average velocity? How is velocity different than speed? Remember, velocity includes a direction. Now, for the record, in physics, we call something that includes a direction a vector quantity. There is scalar, which is just a number, and then there is vector, which is a number in a direction. So when you were running in the hallway out there, you were running 5.26 meters per second, or whatever your answer is, right? Your answer, south. Because velocity is speed in a direction. So now my speed in meters per second is whatever you just calculated it to be. Now, meters per second doesn't help you because it's hard for you to visualize meters per second because we don't do anything in the United States in meters except irrelevant sports like swimming and track and field. Okay? So I want you to calculate your speed in miles per hour, which means for Nevaeh, my average speed is going to be 5.26 times 2.24. So what you're going to do is you're going to take your meters per second times 2.24. Nevaeh, what do you get? 11.7 what? 11.78. This is going to be miles, MI, per hour. Now, this is what you want to pay attention to. Because now we're going to use this answer. We're going to use either our miles per hour answer or our meters per second answer to answer the next few questions. So at your average speed, calculate how long it would take you to run 100 meters. So what is the unknown? Nope. How long it would take you. So what am I solving for? Distance, speed, or time? I'm solving for time, which means my equation is distance over speed. Now, the number substitution, what's the distance that they want me to run? Nope, 100 meters. So I'm going to take 100 meters divided by your meters per second. I'm giving you about 30 seconds to finish the math. And then, Nevaeh, I'm going to ask you for your answer. What? Okay. Now, what am I looking for? Time, which means if I cross off my common units in my problem, what am I left with? 19.01 seconds. Okay. So now, the world record for the 100 meters is 9.58 for men and 10.49 for women. Let's say we're going to put you on the track next to the world record holder. I want to know how far down the track you would be when they finish the race. So if they can do 100 meters in 9.58 seconds, and you're not a world record holder, are you going to be able to get 100 meters down the track? Probably not, right? You're going to run less than them because they cover more meters per second than you. Okay? So, what is the unknown? Distance. So, what's my equation? If the unknown is distance, what do I have to do? Speed times time. So what's my equation? Distance equals speed times time. Now, I've got to take my speed in meters per second. So I'm going to write down, you're going to look for your speed, so your meters per second, times what? Not your seconds, their seconds. And their seconds for the women is 10.49. And their seconds for the men is 9.58. Nevaeh, what's your answer? For the women, how far did you get? So your meters per second, you took 5 times 6 times 10. So this answer right here, you got to take your meters per second, and then you've got to plug it in down here. Okay. So at that speed, remember the unknown is the distance. So how far would Nevaeh travel? About 55 meters. How far would you travel at the men's time, Nevaeh? About 58 meters. Okay. I'm letting you finish that up so you can write your answers in. I'm going to give you about 15 more seconds. All right, so now, what is the world record speed for both men and women's records in miles per hour? So what do I have to calculate? What's the unknown? Speed in miles per hour. Now, what is speed equal to? Distance divided by time. So the first thing you're going to have to do is calculate speed for the men's and the women's. So let's start with 100 meter. And the women's record is 10.49. What do you get? Okay. 9.53. Now this is going to be meters per second. Is that what they're asking me to do? No, they want to know miles per hour. So now I have to take this times 2.24. And what do you get? What do you get? 21.34. And that's miles per hour. You do the men's. Remember, speed is equal to distance divided by time. Micah, what'd you get? Okay, so 23.36 miles per hour. And I think Sione in his 10-meter flies last year went 21, maybe 22. Okay, that kind of gives you a point of reference. Okay, now we're going to switch it up. Now we're going to go, we're not going to leave those distance runners out. We're going to go from speed, right, which is 100 meters, which is awesome, but let's go to the marathon. Because I want to know how long in hours it would take you to run a marathon, which is 26.2 miles, at the average speed that you ran in the 50 meters. So the first thing I want to know is time. What's the equation for time? Time is equal to what? Distance over speed. Now the distance is going to be 26.2 miles. And the speed that you're going to use is your miles per hour. Which is on the front, which is, at least for Nevea, 11.78. Nevea, what do you get? 2.22. Now keep in mind, this is miles per hour. Cross off my miles, I'm left with hours. So at that speed, you could run 26 miles in 2 hours and 22 minutes. Now, I don't know if any of you are distance runners, but I did run a marathon. Run 2, actually. I don't know. Therapy. I did. My best 4 hours and 17 minutes. I did not walk it, jerks. I did struggle at mile 23, and I was in tears. So, 1 mile. Oh my gosh, not to Sioux City, yuck. All right, let's do this last one, okay? All right, the world record for the marathon is 2 hours and 3 minutes and 59 seconds for men, and 2 hours, 15 minutes and 29 seconds for women. If you were to race the world record holder, how far would you have to run when they finish the race? So what am I missing? I'm missing distance. What is, yeah, so speed times time. Now this is one where you want to do your speed, which in miles per hour is this answer up here, times their time. So one would be times 2.07, and another would be 2.26. Now, Tolson, what do you get? I don't care. Give me one. So you would run 25.5 miles and they would be done. Okay. What was the other one? Okay. How is it possible now? So that would be 27.84 miles. Did anybody else run over 26.2 miles? Okay. Let's talk about why. Because I'm going to assume that you're not a world record holder. I mean, maybe, but I'm going to assume you're not. So why is it that you would run farther than them? Yeah, because you don't add fatigue, right? Like you're just running 50 meters and you're taking your top speed for a 50-meter time, and then you're multiplying that by 26.2 miles. So you're not really factoring in fatigue. Now, for the record, there has been a world record set holder that is now under 2 hours. So I think it's 158.75 now. 26.2 miles.